Alright, so we are coming to the very last part of chapter 5, which is it is about the error of hypothesis test. Okay, so in this part, generally we need to calculate the errors that we might make. Okay, what is the probability that we might make an error when we are running out the test or when we are carrying out the test? Okay, so we have two types of tests, two types of error actually. So we have type 1 error and also type 2 error. Right, so what is the learning outcome for this one? Mainly we are going to understand the term for type 1 and type 2 error, and also after that we need to know how to calculate the probability for these two errors here. Right, okay, so let's start. Okay, so when you carry out a hypothesis test, there are four possible conclusions, two of which led to a correct decision, and then another two will lead to the wrong decision. Okay, so the errors associated with the wrong decision making, right, we call it as type 1 and type 2 errors. Right, so in a test, there are two types of error which can occur. So we are having type 1 error and type 2 error. All right, so now actually when we are carry out the test, right, it is not always that we will make a correct decision. Sometimes we'll make a wrong decision. All right, so we need to know also what is the percentage or probability that we will make a wrong decision in the hypothesis test, and all this can be calculated. So we call all these wrong decision making as errors. All right, so from here you can see that if when in fact the actual fact, if let's say the null hypothesis is true, right, if you accept the null hypothesis, means that you are making a correct decision. So there's no error. But if let's say the null hypothesis is true, but when you use a sample and do the calculation and carry out the test, right, you might get a result that you reject the null hypothesis. When the null hypothesis is true, but you rejected the null hypothesis, so we call it as an error already. You make an error because you reject something true, correct or not? So this is the first type of error, and we call it as type 1 error. Okay, then now the same case happens here. If let's say the null hypothesis is false, but when you carry out the test, right, all the data, all the calculation in the sample shows you that you should accept the null hypothesis. But actually, in fact, the null hypothesis is false, but you accept something which is false. So you are making another type of error. So we call it as type 2 error. All right. So if let's say the null hypothesis is false, and when you carry out the test, you make a decision that you reject the null hypothesis. That means you reject something which is false. So you make a correct decision. All right. So you are having four outcomes here, and then there are two. Okay, with errors one. So we call it as type 1 error and type 2 error. So for this part, generally before you want to calculate the probability for type 1 and type 2 error, you need to remember the definition for type 1 and type 2 error first. All right, so this is the summary from the table. All right, and then I think you better can remember this one. We define the errors as what is the type 1 error. So type 1 error means that you reject the null hypothesis when null hypothesis is true. Okay, and then for type 2 error is you accept the null hypothesis when the null hypothesis is false. Right, so this is what we have all the definition for the errors type 1 and type 2. So please make sure you remember this, because you will need it very often when you want to calculate the probability for type 1 and type 2 error. All right, so usually in calculation, when we want to write out the probability for type 1 error, we write out like this. So type 1 error, it is actually reject null hypothesis given that null hypothesis is true. So this one seems like a conditional probability sign, right? Okay, so it is a symbol for conditional probability, but no need to too worry about it, because when you calculate the probability, right, we don't really involve it. But the meaning is that the meaning is under the conditional probability. All right, so usually we write out the definition like this, the formula. Okay, so when we are talking about rejection, the null hypothesis, in the calculation part, you need to put in the rejection region. Okay, all right, so I will show you later how we do this. Okay, then for type 2 error also the same. For type 2 error, when you write out the probability, right, it will be probability accepting the null hypothesis given that the null hypothesis is false. Okay, so this one is given that. So we're given that is a formula, okay, of the part under the conditional probability. So this is given that, and this is also given that. So you accept the null hypothesis given that the null hypothesis is false. So for the accepting null hypothesis part, right, in the calculation, you need to put in some value. So that value you need to put in the acceptance region. Okay, so again, I will show you all the details for calculation in the next video, all right, or maybe in discussing the example. All right, so to calculate the probability of a making type 2 error, so you must be given a specific value for alternative hypothesis H1. Okay, when null hypothesis is false, that means you don't have the correct value for the null hypothesis, right? So you will be given a specific value for the alternative hypothesis. So again, all this I will discuss in more detail when we discuss the example. All right. Okay. Then now, a type 1 error involves rejecting null hypothesis. Okay. So type 1 error, what kind of error is this? It means that when you reject the null hypothesis when null hypothesis is true. So that means if a test, when you run a test, right, your final decision is you accept the null hypothesis, then you cannot make type 1 error, you can only make type 2 error. So the same thing happens. Type 2 error means that you accept the null hypothesis when null hypothesis is false. So when you carry out a test and the result that you get is reject the null hypothesis, so for this kind of test, that means you cannot make the type 2 error, but you can only make the type 1 error. Because type 1 error means reject the null hypothesis, right? When null hypothesis is true. So if you, in your test, you reject the null hypothesis, the only possible error that you make is type 1 error. All right. Okay. So this is some very basic concept all right, about the hypothesis test with the error, type 1 and type 2 error. All right, so for this part in general, they usually just ask you to calculate the probability for these two errors only. But the problem is for some of the questions, it can be quite complicated because it involves different distribution, and then they have two errors here, and then sometimes they will want you to find out the rejection region, okay, the rejection region and also the acceptance region yourself before you can calculate it. So it makes the question become slightly more complicated. All right, okay. So no matter how, let us start with our very first part of the error. All right, so now we focus on type 1 and type 2 error that involve the normal distribution first. All right, then later we have some binomial distribution example, and after that we have the Poisson one. Right, so we go through different distribution, and we discuss different differentiation one by one. Okay, so the learning outcome 5.5 here, they want you to calculate the probability for type 1 and type 2 error. Okay, in specific situations that involve normal, binomial, or Poisson. All right. Okay, so for this, all the explanation here is for normal distribution. Okay, so let us start. Okay, so when the distribution of the test statistic is continuous, so which is normal, in our case, we have only normal distribution here. So you always remember the probability of type 1 error is equals to significance level. So please remember this one. The probability of type 1 error equals to significance level. And this applies only in normal distribution in our case. All right, in our syllabus, because in our syllabus, you only learn normal distribution for the test hypothesis testing. All right, so when they say, okay, calculate the type 1 error probability of normal distribution, then you straight away look for the significance level, which is the alpha, okay, usually given by the question. Okay, all right. Then now, when we want to calculate type 1 and type 2 error, right, generally you need acceptance region and rejection region. So most of the time, maybe I shouldn't say most of the time now, right? Sometimes the question will give you the rejection region in the question straight away. So if let's say the rejection region is given, then your work will be very easy. You just need to apply the formula, then calculate the probability. But the problem is if the rejection region is not given, then you have to find the rejection region first before you calculate the probability for the error. Alright, so to find the rejection region, you need to know what is your significance level first, and usually the alpha will be given in the question, right? Okay, so this is a guideline for you. We have one tail test, two tail tests. Okay, one tail test left, one tail test right, and two tail tests. Okay, to calculate the rejection region. But I just want to let you know, you don't need to purposely go and memorize this one. Okay, but I just want you to remember that for normal distribution, right? This is the formula for the test statistic. Okay, you don't look at this one. So it is equal sign, let's say. Okay, so you just remember that you are using the test statistic formula, okay, to get the rejection region. So in calculation part, okay, in the example part, later when I show you, I will generally use a diagram to help me to remember it. All right, but first thing you need to know is when you want to get the rejection region, okay, in normal distribution, then generally you need to know that you are using the test statistic formula. Okay, all right, so we can start now. Let's have a look for example 28. All right, so if you look at example 28, when you read through the question, all right, so first you get a keyword. So the keyword, the first keyword here will be normal distribution. Okay, so from here you know that it is normally distributed, and then the mean is 21.2, standard deviation is 7.3. So from here they are talking about the population. So this is mu, and this is population standard deviation. Okay, so a researcher claims to have discovered a previously unknown book by this author. The mean length of 90 sentences chosen at random in this book is found to be 19.4. So now 19.4 words is for the 90 sentence one. It is not from a book, all right? So from here you should know that this is your n, okay, a smaller sample, which is the n, and then this is the mean for the group for the 19 sentences, right? Okay, so how you know is the mean? Here they say mean length, right? So the mean length means that this is a sample size. Sorry, sample mean, okay, which is x bar. All right. Okay, so first, assuming the population standard deviation of sentence length in this book is also 7.3, okay, then test at the 5% level of significance whether the mean sentence length is same as the others. So state your null and alternative hypothesis. Okay, so first of all, you need to decide what is your null and alternative hypothesis. All right. Okay, so from here, you know that your population mean is 21.2. All right, so very obvious that your null hypothesis will be mu equals to 21.2. Okay, then after that, they are asking for the alternative, right? Which word tells you about the alternative hypothesis? Okay, it is this one. The word same. They want to know, okay, whether the mean sentence length is the same as the others one. So either same is equal sign, all right? So that means the opposite meaning of the same is not the same, right? So not the same, when you want to form the alternative hypothesis, it will be mu not equals to 21.2. All right, so which means that the mean sentence length is not the same as others. Okay, so this is what they want for part number 1. Okay. All right. So now after that, this is your first step lah. Then they want you to test at the 5% level of significance whether the mean sentence length. So that means you need to continue with the test lah. All right. Okay. So you already write out the first step, which is now an alternative hypothesis. Okay. Then now to carry out the test, second step, you need to I already forget. Second step, usually I ask you to draw the diagram or I ask you to calculate the test statistics, but it doesn't matter lah, all right? It is either second or third step only within this. All right, so maybe for the second step, what am I going to do is that I will ask you to draw a diagram first. Okay, so this is a normal distribution, right? Therefore, you should have a bell-shaped curve, and then the error will be on both sides. Okay, so both side error is at both sides. Then after that, what is the probability? Okay, or what is the area for both? So for this one, it should be 0.025. Okay, and then this is also 0.025. And then you need to find out the critical value at the border here. So what is the critical value? You need to find out this critical value from the table, the normal distribution table lah. So I hope you still remember how to do it. So you should have 1.96 here for the critical value. So another critical value, this one will be negative 1.96. So this is my second step. I get the critical value first. Okay, then now proceed to the third step. So for the third step, you need to calculate the test statistic. So I hope you still remember all the steps here lah, to carry out the test. So the test statistic is Z. Okay, so what's the value of Z here? Sample mean, which is 19.4, minus the population mean divided by standard deviation over square root n. Alright, so from here, the value that you get will be negative 2.34. Okay, so this is the negative 2.34, which is your test statistics. Then after that, you want to put in your test statistic into the graph. So negative 2.34 will be here, which is after, or should I say before the negative 1.96. So this is actually negative 2.34. So from here, you can see that the line for this test statistic, right, it falls under the rejection region. So from here, you can make a decision now. So what's your decision? So you can say that you are going to reject the null hypothesis. Alright, so which means what? It means that when you reject the null hypothesis, means that the mean sentence length is not the same as the others one. Alright, so this is what you have for part 1. So you carry out a test by using normal distribution. Okay, so I hope that you still remember all the detailed steps here. Alright, okay, so now let us proceed to part number 2 in this example. Okay, so for part number 2, they want you to state in words relating to the context of the test. Okay, context of the test means that they actually want you to write out by using the sentence or by using the statement that is related to the question. Okay, what is meant by type 1 error, and state the probability of a type 1 error in the test in part 1. Okay, so they want you to write out the definition for the type 1 error. But when you write out the definition for type 1 error, you need to use the situation for this question. Alright, okay, so maybe you can state the probability for type 1 error first. So what is the probability for type 1 error? So for this example, you know that it is a normal distribution, right? Therefore, the probability for type 1 error will be the alpha, which is 0.05. That's it. Okay, this is normal distribution, so it is continuous. Therefore, you should always write type 1 error equals to the significance level. Okay, then now we want to write out the definition. The words are in the context of the test. So type 1 error means that reject. Okay, so maybe I try to recall back. Definition for type 1 error will be reject null hypothesis when null hypothesis is true. Okay, so now if you reject the null hypothesis, okay, that means we make a conclusion that this is correct, right? Alternative hypothesis is correct. Okay, so you can write it like this. We conclude means we ourselves who run the test, right? Make the conclusion. So what is the conclusion that we make when we reject the null hypothesis? So we conclude that the mean sentence length is not the same as others. Okay, this is what we do, what we concluded in our test. Okay, but in fact, okay, it is the same as others. Okay, so I don't know whether you understand the idea or not. All right, so this is the conclusion part. This is what we make. All right, so we reject the null hypothesis. But actually in the real fact is the mean length is actually the same as others, but we reject or we conclude that it is not the same. So this is the meaning of writing the type 1 error in the context of the test. All right, so you cannot write out like reject null hypothesis when null hypothesis is true. They won't accept this one. You need to express it in a way of which is similar to what they ask you in the question. So in the context of the test. All right, so again, one point which is very important is this one. When you are having a normal distribution, right? So the probability for type 1 error will be equals to alpha, only for normal distribution in our syllabus. All right, okay, so this part you will see that it didn't involve any calculation for type 1 or type 2 error yet, but we just state the value. All right, okay, so for the next example, we are going to learn okay, how to calculate the probability for errors. All right, so I will stop here for this video, then I will continue the discussion in